Okay, in this video, we're going to solve systems of equations using the method of elimination, which is what it sounds like. We basically want to eliminate a variable initially to solve for the other variable. So let's look at these two examples. What we first want to do is we want to make sure that it's x, y, and the constant is on the other side, and x, y, and the constant is on the other side for both equations. And then we're going to write them one on top of the other. Okay, so now I have 3x plus 2y equals 9. And what we're looking for is we're looking for one of the variables, either one of them, to have the same coefficient. So here's my y, they both have 2's. As long as that happens, I don't have to do any extra work to be able to do elimination. So this one's set up already for us in a way that we don't have to do extra steps. Now, I do have to make this 0. I want this 2y and this 2y to become 0. So I have to decide, am I going to add these two equations or am I going to subtract? Since they are different signs, -2 and +2, when we add them, make 0, I'm going to add. If they were the same signs, I would subtract. But this tells me what I'm going to do to every other term. So 5x plus 3x is 8x. -2y plus 2y is 0, so we're not going to write that, equals 7 plus 9 is 16. And so now what we have is 8x equals 16, and we can just go ahead and solve for x by dividing both sides by 8. So we now know that x is equal to 2. With any systems of equations, we have to make sure that we find both x and y. We can't just stop here. We need to know both values. So now we're going to take the fact that we know x is 2, and we're just going to plug it into one of our equations and solve for the other variable. So it doesn't matter which one you use. I'm just going to use this first one here. So 5x minus 2y equals 7, and I'm going to replace x with 2 because those two are equivalent. So x is 2. And 5 times 2 is 10, minus 2y equals 7. And now I just want to solve for y. So I'm going to move the 10 to the other side by subtraction. So I get -2y, don't forget that negative there, -2y equals -3. Divide both sides by -2, and I get y equals, now negative over negative is positive, and I'm going to leave it as a fraction, 3/2. So the last thing I want to do is I want you guys to always write it as a coordinate pair. So we're going to write the x value first, which is 2, and the y value, which is 3/2. And this is my answer. And those are the coordinates that satisfy both equations. They make both equations true. And this is the point on a grid where those two lines intersect. Okay, let's look at this example. Again, we have x, y, and our constant on the other side, and x, y, and our constant on the other side. So they're set up the way we want them. So I'm going to write one on top of the other. Down here, we're going to write 5x plus 2y equals -6. And then I need to look and see, is there a variable that has the same coefficient? So these x's, this is a 3, this is a 5, that doesn't work for me. And here's my y's, and this is a 4, and this is a 2, so that doesn't work either. So it's not set up nicely. We have to do something to it to make it work for us. So we're going to ask ourselves, is there anything I can multiply 5 by to make 3? No, there's not. Is there anything I can multiply 2 by to make a 4? Yes. In this case, I can multiply this whole equation by 2. Now, you could actually multiply either equation. If there was a number I could multiply 3 by to get 5, I could do that, or 4 by to get 2. Obviously, I can multiply by 1/2, but that makes things more complicated. So I know that 2 times 2 is going to give me 4, and those are going to match. So I'm going to do that one. Now, I'm going to rewrite this one over here just like we see it, because we're not multiplying this equation by anything. But when I do this, I have to multiply every single term by 2. So 5 times 2 is 10x, and 2 times 2, or 2y times 2, is 4y, and then -6 times 2 is -12. So by doing that, it got me the same coefficient for y here, okay? So that's the goal. The goal is to make it so that one of your variables has the same coefficients, and you can multiply by whatever you need to multiply by. So now I just have to decide, am I going to add or subtract? Well, these are the same signs. So 4 plus 4 would give me 8, and that's not what I want. So I have to subtract here. That tells me I'm going to subtract every term from what's on, or the top from what's on the bottom. So 3x minus 10x is going to give me a negative 7x. 4 minus 4 is giving me 0. I'm not going to write that. Equals 30 minus negative 12, be careful with that, is going to give me 42. So I have negative 7x equals 42, and I can just divide by negative 7 to solve for x. So x in this case equals negative 6. Again, we do have to find y, so I'm going to take this x equals negative 6, and I'm going to plug it into either one of my equations. It doesn't matter, so I'm just going to use the first one, which is 3x plus 4y equals 30, and in place of that x, I'm going to put negative 6. So 3 times negative 6 is negative 18, plus 4y equals 30. When I move the 18, it's negative, so I'm going to add it to both sides. I get 4y equals 48. Divide both sides by 4. Y equals 12. So I have my coordinates now. I just want to write them as a coordinate pair. X was negative 6. Y was 12. Okay, we're going to look at one more example. Okay, on this example, this equation is not in the form that I want. This is x, y constant. This is x, and it's got a constant, and then the y's over here. So I do want to rearrange this. So I'm going to take this 2x plus 4 equals 3y, and I'm going to move the 3y over here with the x. So I'm going to subtract it. That's going to give me 2x minus 3y plus 4 equals 0, and then I can just move the 4 to the other side. So we're just manipulating this equation, being careful with our signs, so that it's in the right form, x, y constant. So now I'm going to take this and this first one that we haven't used yet, and I'm going to write one on top of the other. So 2x minus 3y equals negative 4, and then 7x plus 5y equals 17. Okay, so now again, what we're looking for is for one of the variables to have the same coefficient. So these aren't the same and these aren't the same. So the question would be, what can I multiply by to make them the same? Well, I can't multiply by 2 by anything to get 7, or 3 by anything to get 5. And I can't multiply 7 by anything to get 2, or 5 by anything to get 3. And when that happens, you actually have to multiply both equations. So pick a variable, it doesn't matter. I'm going to pick x. I'm going to make those the same. So I know that I can multiply this top one by 7. 7 times 2 will be 14. And the bottom by 2, because 2 times 7 is 14. And so then these will match. So 7 times 2 is 14x. 7 times negative 3 is negative 21y. And 7 times negative 4 is negative 28. So now we're going to do the same thing to the second one, only we're multiplying by 2. 2 times 7 is 14x. 2 times 5 is 10y. And 2 times 17 is 34. So now I have this systems of equations here, and see that my x's match. I have 14 for both. Now we have to decide, are we adding or subtracting? Because we can do either, but we have to choose the correct one that's going to make one of our variables cancel. So 14 plus 14 doesn't give me 0, so I'm going to subtract. 14 minus 14 is 0, but negative 21 minus 10, be careful with your signs, is going to be negative 31y. Negative 28 minus negative 34, again, be very careful with your signs, is going to be negative 62. When I divide by negative 31, I get that y is equal to positive 2. Okay, so now we've solved for y in this case. We do have to go back and we have to solve for x. So I'm going to take y equals 2 and I'm going to plug it into either equation. It doesn't matter which one. So 7x plus 5y equals 17. And then I'm going to replace the y with 2 because we know already that y is 2. We solved that over here. So 7x, 5 times 2 is 10, equals 17. Move my 10. 7x equals 7. Divide by 7, and x equals 1. So my coordinate pair, we solve for y first. We have to make sure that we always write the x first in our coordinate. So x is 1 and y is 2. And that's the solution to my systems of equations. Okay, that was elimination. There is a video on substitution as well if you need to watch that. And we will see you in the next video.